What's going on YouTube? Coach Carr here bringing you another video. This one is on, still in our quadrilateral notes, and it's on pages 8 and 10. And I hope you enjoy. So your success criteria for this one is just like the other ones. You'll be successful when you can solve problems using the properties of different quadrilaterals. And the learning target comes from the GCO 3.11, and it's to prove theorems about parallelograms, use theorems about parallelograms to solve problems. Okay, so now we're looking at number 8, or page 8, number 14. It says that ABCD is a square. Find values of W, T, line segment AB, and line segment AC. Leave answers in radical form. Okay, so a few things you need to know if you're dealing with a square is that all sides are congruent. So this side, this side, this side, and this side are congruent. Another thing to know is in a square, all angles are right angles. And when you have a diagonal, in a square, they actually cut these angles in half. So this is 45 degrees. This one is also 45 degrees. So I have labeled everything I know about these. So the first one we're going to want to try to find is actually W, because the sides have to be congruent. So these sides are the ones I want to choose because they both have the variable of W. So if they're both congruent, that means they're equal. So I'm going to have W plus 12 equals 3W minus 22. Next step is to move all the variables to one side and everything without a variable to the other. So I am going to subtract W first. And now you have 12 equals 3W minus W is 2W minus 22. Now I want to add 22 to both sides, and 34 equals 2W. Now I want W by itself, so now I'm going to divide by 2. And 17 equals W. So now, since one of the things I also want to find is the length of AB, I can actually just plug this into that equation now. So in that case, AB, line segment AB, is supposed to be equal to W plus 12. Well, instead of W, I'll put in the 17. So line segment AB is equal to 17 plus 12. Add those together, and the line segment is equal to 29. So each of these side lengths is actually 29. So this side's 29, this side's 29. All of them are equal to 29. So now if I want to solve for T, I can actually set it equal to that. So in this case, you have 5T minus 6 equals 29. Next step would be to add 6 to both sides. And now it's 5T equals 35. Now I want to get T by itself, so now I'm going to divide by 5. And T equals 7. So now We have found W, we found T, and we found line segment AB. The last thing they want us to find is the line segment AC, which is our diagonal. So because we see what kind of angles we have, we can actually deal with one of our special right triangles, a 45, 45, 90 triangle. In these kind of triangles, the legs are congruent to each other, and we can represent it as x, and the hypotenuse is going to be x times the square root of 2. So since we know in this case our side lengths are 29, instead of the x we would have 29. So really, line segment AC is equal to 29 times the square root of 2. And since they want us to keep it in radical form, we would leave our answer just like that. Okay, so now we are on page 10, number 21. It says UVWX is a parallelogram with the given measurements. Find the following. The measure of angle WVU, the measure of angle XUV, line segment WV, and the line segment UW. Okay, so let's just go ahead and go in order of how they have it. So the first thing that they want us to look at is angle WVU. So WVU would be the entire angle right here. So if you notice, I have the different properties off to the side. What's going to help us here is that opposite sides are parallel. And the reason why that's going to help us is so this side is parallel to this side. If that's the case, this could be considered a transversal, and these would be my different parallel lines. So here, if this is 29 degrees here, it's also 29 degrees here because of alternate interior angles. So then if this one is 17, then 17 degrees is also right there. Because again, because of alternate interior angles. So to find the full angle, what I would want to do to find angle WVU would be to do 29 plus 17, because that's the full angle. When I add those together, I get 46. So angle WVU is equal to 46 degrees. Okay, so now the next one they told us to find was angle XUV. So XUV is this full angle right here. They want the full thing. Now, the property that would help us the most for this is that consecutive angles are supplementary. So that means they have to add up to 180. So if I go consecutively, so like from here to here, these would have to add up to 180. So if I already know that this angle here is equal to 46, what I would want to do is do 180 minus 46. When I do that, I'm going to get 134. So angle XUV is equal to 134 degrees. Okay, so now the next thing that it wanted us to find was WV. So to find WV, the thing that's going to help us here is that opposite sides are congruent. So if XU is 24, that would mean this side is also 24. And if this side is 41, then this side is 41. So the one that we're trying to find here, the line segment WV, WV is this side, so it's equal to 24. And now the last thing is the length of UW. UW is the full length here, the diagonal. And what's going to help us here for rules is that the diagonals bisect. So if they bisect, they're cut in half. So if this side is 15, this side too is 15. So if I want to know the full length of UW, then what I would want to do is add them together, and that's going to get me 30. So in this type of problem, you really need to know all the different properties of this particular shape. That's the end of this video. Thanks again for watching. Make sure you do exit slips 1 through 3. So these problems are, you have an example of each type of shape, and you're going to have to actually solve it using these properties that we went over on the first page. So make sure you do that, and also like, subscribe, and turn on them notifications.